Okay, welcome back everyone. This is lecture 9, part 3. So we had developed or started to develop the rational powers in the previous part. So we are going to investigate that table a little bit. Once the Newton was satisfied with his interpolation method, he sort of began searching for a pattern in the columns. We're talking about the previous table, which hopefully will allow him to continue each series this way without having to go through the tedious work of actually computing all the entries for each row. So he noticed the following. So for example, in the previous table, I'll bring the table back in a bit, for where power was half, let's see what he noticed. Okay, so this is power half. This is power half. Now, I know that I told you that you should complete as homework row 2 and row 4 using the very same method as the example that I did a little earlier. But I went on and I completed the rest of the table, and I left these two rows not completed. Nonetheless, it's worth mentioning the pattern that he actually noticed. While I explain the pattern, I am basically giving you a way to complete most of the entries for row 2 and row 4. However, for homework, you're gonna actually have to show work using the systems of linear equations as I did in the example that I did in part 2. All right, so for example, for part p equal to half, for the square root of that polynomial. So what is it that Newton noticed? He noticed that the entries in this column, all the entries in this column, were actually produced by continued multiplication. For example, 1 over 1 times 1 over 1 times half gave you the first entry here. Gave the first entry here, and then the third entry, which you will find by some other independent work from what I'm saying, actually comes from multiplying half with minus 1 over 4. And then the fifth entry comes from multiplying that number by minus 3 over 6. And then the next entry comes by multiplying by minus 5 over 8. And then the next one by minus 7 over 10. And the next one by minus 9 over 12. And the next one by minus 11 over 4. So each of these entries in this column will come from continuous multiplication of these fractions. Again, you can figure out what these two numbers will be here, but that's not a point. I repeat, as homework, I would like you to actually show the work solving those linear equations. So, but for the sake of our argument, all the entries in this column are he noticed that are completed by doing this continuous multiplication. So what's so special about this pattern here? What is it that we notice? We notice the following: that the numerators are all decreasing by 2. So here, I should say, is the continuous multiplication. That gives every entry. Entry in the column. in this case the column p equals to half. Okay, so note the following here. Note that the denominators, I'm sorry, not the denominators, the numerators are all decreasing by 2, are decreasing by 2. One, well, ignoring the first one, so minus 1, minus 3, minus 5, minus 7, minus 9, all decreasing by 2. By 2. Okay, so what can you say about the denominators? The denominators are increasing by 2. And 2, 4, 6, 8, 10, 12, 14, and so on. This is 14. Okay. And denominators are increasing by 2. Okay. Similarly, in the same column, the column 3 half, similarly, in the column for p equals to 3 halves, which is this one here, all the entries, all entries are produced by the following continuous multiplication, which is 1 over 1 times 3 over 2 gives you this. Then if you multiply by 1 over 4, you're going to get the next entry, and then you multiply by minus 1 over 6, you're going to get the next entry, and then times minus 3 over 8, you're going to get the next entry, times minus 5 over 10 will be the next one, then times minus 7 over 12 would be the next one, times minus 9 over 14 would be the next one. Same thing here, the same thing here. The denominators, the numerators are decreasing by 2, so numerators are decreasing by 2. And denominators are increasing by 2, same thing. And denominators are increasing by 2. Okay, so to further investigate what Newton did is he carried out some more interpolation and came up with another table. This is a table much like we did the previous one, but of course with a lot more work. Now, not only for these fractional powers, the powers where the denominator is 3, so power 1 over 3, 2 over 3, 1 or 3 over 3, 4 over 3, 5 over 3, 6 over 3, 7 over 3, and so on. And so he completed the table, and this is the table. Obviously, now that we know what needs to be done, is not interesting in showing the tedious work, but nonetheless, this is the table. So for this other power, he also, if you carefully look at the numbers, for example, for the column p equal to 1/3, what did he notice? So also for p equal to 1/3, as in table 3, so this is your table 3, he noticed the following, that entries were produced, entries are produced by doing what? By multiplying. So here we're talking about this column, are produced by doing the following: 1 over 1 times 1 over 3. Then the next one, meaning the minus 1 over 9, minus 1 over 9 comes by multiplying this by minus 2 over 6. Then by multiplying that result by minus 5 over 9. Then by minus 8 over 12. By minus 11 over 15, and so on. So here, the numerators here, numerators decrease by what? By 3. Here, numerators decrease by 3. 1, minus 2, minus 5, minus 8, minus 11, you're decreasing by 3. So, decreasing by 3. And numerators are denominators, what am I saying? Denominators are increasing by 3. And 1, 3, 6, 9, 12, 15, and so on. And denominators are increasing by 3. Are increasing by 3. So at this point, Newton wrote down an explicit formula for the binomial numbers in some arbitrary column p equal to x over y. So for some arbitrary column, obviously he did compute many more tables like this. So the pattern was the same. So for some random column p equal to x over y, meaning the x over y power of some polynomial, he noticed the following. He deduced rather that the entries were produced by multiplying 1 over 1 times x over y times x minus y over 2y times x minus 2y over 3y times x minus 3y over 4y, and so on. So dropping the first term and letting n be equal to x over y, then this becomes the well-known formula: n times n minus 1 over 2 times n minus 2 over 3 times n minus 3 over 4, and so on. So dropping the first term, and letting n be equal to x over y, this becomes now what? This becomes really the following: n over 1 times n minus 1 over 2 times n minus 2 over 3 times n minus 3 over 4, and so on, which is the formula that you know for your binomial coefficients. And that's basically the end of the part 3. So your job actually is to work through 2 columns of the previous table as far as the homework for this particular topic is concerned. Until next time, everyone.